All right. So that's that. What do we get on the other side? Anybody?
HCl.
HCl for one. Good.
And then you draw the same structure, just with a dot where the two hydrogen.
Right there?
Yeah.
Okay, excellent. Following? We're following online? All right, the last one we're going to look at is the terminal carbon, that CH3 that's on the end. But nothing is going to change. It's just going to be in a different location. So take 10 seconds and write that abstraction. Take 30 seconds. We got 10 minutes left. And I want to get through termination and to the calculation part. So the last one that we're going to pull with is this one right here. All right, take 30 seconds and put those arrows in. They don't change. All abstraction happens the same way. You're going to cleave a bond homolytically. You're going to make a bond homogenically. And it will never change. I don't care how big the molecule is. If you're doing abstraction of a hydrogen through a radical mechanism, it does not change. All right, anybody got it online already? You want to annotate it and show and draw those arrows in? No takers. What? Jumping at the beat. I saw your eyes. I got it.
I just draw the arrows, right?
Yeah, just put the arrows in. Okay, great. That will never change. If you're doing, thank you. If you're doing abstraction of a hydrogen using a radical, that's how it happens. Every single time. We're gonna do this, and then one more arrow going back to R. All right, thank you, Chase. All right, what do we get as a result of that? What's my radical on the other side gonna look like?
C3 plus that same structure, just instead of 3 hydrogens,
Right.
you'll have 2, and then a lone.
Lone electron, like that?
Yeah.
All right, so all of these are what we call propagation steps. And in propagation, you do abstraction. In abstraction is you take an electron from your radical initiator, donate it towards one of the CH bonds, and cleave it homolytically. What? Any questions?
I have a question.
Go ahead.
You probably already said it. But, I just want to reiterate the
Right.
original problem.
Mhm.
It was that the skeleton form with Cl2 over H. How did you get 3 figures though?
3 products, yes. That's because there's another step in the mechanism where we put the chlorines in. If that's what you're asking. So this propagation step is setting us up for termination, which is the last step.
So it was supposed to be 3 figures?
Yes.
That we're supposed to do?
Yes.
Okay.
Yes. And now let's take our radicals from the propagation step, and we're going to put them right down here, there where it says termination. So it's going to be this plus Cl radical. And this one plus the chlorine radical. And it'll be this one plus a chlorine radical. You can see right away, again, I never run out of chlorines. All I need is 1 mole of chlorine, and I have access to several billions of chlorines. Good so far? Now, what I'm doing in termination is combining radicals. All right, to get to my products. So I want to combine that chlorine with that carbon. How do I show it? What? I need some arrows, don't I? That's how we talk in organic, using arrows, right? So I'm going to say here, this is going to happen. Is that right?
Yes.
And then when that does happen, this is my product. Yes or no?
Yes.
Yeah. Right. The termination part is the easy part. The propagation part is probably the most difficult. All right, then I want to do this. I want to take these two, combine them. That's going to give me that second product. Do you agree? All right, and when those two radicals see each other, they're coming for each other. It's that simple. Both are highly reactive. That's why radical chain reaction is not the preferred method to make alkyl halides, because you get so many different products. Right? Here, same thing. All right, and let me write that CH2 back in. So it's CH2. I'm going to go here, here, and then my product will look like this. So now I have a bond between that CH2 and chlorine. Any questions about the termination part? Never changes.
I have a question.
Go ahead.
So are these all possible answers or all of them together is the
No,
answer?
it's the combined answer. You get all three.
Okay.
That's the, okay, so
Thank
that
you.
leads to the next question. How much of each am I going to get? And you can calculate that using, we got 4 minutes. I think we can do it. How much of each product do I get? Right? But the fact that you have a competition between the radicals, that's going to lead to what's called a product distribution, which is just simply a ratio of products. So just write this term down. You're going to see it again. Just a ratio. That's all that means. It's a big phrase, but all it means is a ratio of products. We call it a product distribution. Meaning you're not going to get 100% of one. It's going to be out of 100. You're going to get some of each. All right. So the way we calculate that is with this little equation down here. So we got to do some math. So it's low level math. So we're going to call it math. Very low level. All right. So it's really two components that we need to worry about, and that's right here. The NHIR. That's in the top and bottom. Let me explain what that is. So HI is the type of hydrogen. Right? That means primary, secondary, or tertiary. That's all that is. And it's how many of them are present. So N right here is how many are present. All right. We're good so far? So, because you're going to have some primary, you're going to have some secondary, so on and so forth. In this molecule, let's look at it. I'm just going to draw. Right, you have right 6 primaries, is that right? 3 on one end, 3 on the other. Both are primary. When we do the mechanism, we don't have to do each side, but when we calculate the percentages, you have to account for both sides, right? And we have 3 secondary types, or 2 different types, right? We got a type here Those two are the same, and then we have another type here, but they're all secondary. You can do this one or two ways. If you want to differentiate between them, then the top number is going to be different. But for the number on the bottom, it doesn't matter. We're going to combine everything. So how many total secondary do we have? We got 3 sites, but it's 6 total, right? There's 2 hydrants on each site. So we have 6 primaries. Got 6 of those, and at the secondary, we also have 6. Is that right? Because each one of these carbons right here is secondary. Are y'all following? The orange and the blue hydrogens are kind of crappy here, but you can see the difference. These two are the same, and then these are different. Is that right? Because they're symmetrical. If I put a chlorine here or here, we won't get the same product. If I put one here, we'll get the same product. Everybody okay? All right, so the only other part of this is R, which is the reactivity factor. That's what's on the table. All right, so if I know N and I know R, I'm good. All right, so let's do for the secondary. Let's calculate that. So for secondary, N is 6, and then R for a secondary carbon reacting with chlorine. So here's the secondary, here's the R for chlorine. So it'll be 6, and then this will be 3.9.
What is it?
PDT? It's a abbreviation for product.
Okay.
Are we okay? Are we good with that? And then for primary, N is 6 because we have a CH3 on each end. And then R for a primary carbon reacting with chlorine is 1. All right. Give me one more minute and then we'll stop.
Can you zoom back onto the manual skeleton structure?
So can somebody calculate 6 times 3.9? It's going to be close to 24. And then 6 times 1 is 6. That's how we're going to get that bottom number, the sum. We're going to add up all the values.
6 times 3.9 is 23.4.
So the sum 23.4 plus 6. Is that right?
Yeah, and if you plus 6, it's 29.4.
29.4. Let me move it. That's my sum of all of my values, 29.4. And then in the top, now I can calculate how much primary, how much secondary, how much whatever. So let's do the primary. So for primary, I got 6 primary hydrogens. So in the top, we're going to put 6 because that's what I got for this, right? So 6 divided by 29.4 times 100 is going to give me the percentage. Primary hydrogens. Right? Now the secondaries, notice I got 2 types. I can lump them together and just get a general number, or I can separate them and do 4 over 29.4 and then 2 over 29.4. Y'all following that? Because I got these 2 highlighted in blue. If I wanted to specify, I could do 2 over the sum. And then here I got these 4, so I could do 4 over the sum. And that'll give me the percentage of each one. Following online or no? Everybody looks glazed over. All right, I'm gonna stop here. We're gonna pick this up again on Monday. All right. Remember, no class tomorrow. I mean, Friday. No class Friday. All right.
The test is still going to open Friday, correct?
Yes, it will. It's going to be the same format. Open Friday, close Sunday. All right. Everybody good? All right. We'll stop here and I'll see you on Monday.